To print a double-sided board, you'll need a computer with the Volterra V-one software,
the Volterra V-one, and, optionally, a rotary drill press to drill the vias.
We will be printing this circuit on one of our own Arduino Uno template boards. This is a convenient option for making custom Arduino shields. First, we need to design the circuit. We'll start by adding the Arduino Uno template to the schematic. The design files for these templates will be available for download through the Volterra website. Add vias to connect the layers, then route the bottom layer and top layer to connect your components. The circuit design files are now ready to export as a Gerber file and to load into the V-one software. Clamp the board and make sure that it's held firmly in place. Then mount the probe onto the printer carriage. Because the template has pre-made features, the V-one needs to know exactly where these are located. To do this, we locate two pads manually, and the V-one software will sort out the rest.
The V-one will now probe the surface of the board. The generated height profile must be very precise to ensure a consistent print height of 100 micrometers. Now the first layer is ready to print. This print should take about 15 minutes, after which the board is ready for baking. Go get a coffee. The circuit will be waiting for you when you come back. Flip the board so it is resting on the ledges of the clamp, then start the bake cycle. Once the bake step is complete, we can drill the holes for our vias. We used an inexpensive PCB drill bit set to make our vias. Alternatively, template boards with pre-made vias will be available if you would prefer not to drill.
With the holes drilled, we can move on to hole plugging and printing the second layer. Apply some masking tape or painter's tape on the first layer. Clamp the board and carefully fill the vias with conductive ink. This will connect both sides of the board. You could do this by soldering a wire through the holes, but we found this method to be both easier and much faster. Wipe down the board to remove excess ink. On the second side, locate two template features and then probe the board. The V-one can now print the second layer. This should take about 5 minutes.
Remove the tape, flip the board, and start the last bake cycle. 20 minutes later, the board is fully cured and ready to be soldered. After locating and probing the pads, the V-one will dispense solder paste onto the cured ink. We'll be using 1206 surface mount LEDs to light up the LED matrix. Using a pair of tweezers, carefully place the LEDs and resistors on their corresponding pads.
Now that the board is populated, the final step is to reflow the solder paste. Using the automatic reflow function will ensure that all components are soldered correctly.
Checking the LEDs with a digital multimeter shows that all our components are properly connected. This PCB is now a working LED matrix. Soldering pin headers to the through holes on the template will make it easy to connect the LED matrix to the Arduino. All that's left is to mount the LED matrix on the Arduino, upload the code, and watch the LED matrix come to life. The code that we used for this demonstration is based on a project by Ian Truslove and can be found on his website brownsofa.org. We've included a link to the project in the description of this video,